Hello. Sitsu is back. Then now, today we are going to answer this question of Coulomb's law, which states determine the resultant electrostatic force on QB. For us to calculate the electrostatic force or the resultant electrostatic force that acts on QB, firstly we must draw a free body diagram. Then for us to draw a free body diagram on B relative to these two charges, we have to consider that we have a negative charge for A, positive for B, negative for C. You can clearly see that B and C, they are going to attract each other. They are going to attract. Then B will move towards the right. Same for B and A, they are going to attract. Then our B will then move towards the left. You see? Then from here we can clearly see that our charges, they are in nanocoulombs. We must convert those nanocoulombs to coulombs. So simple. We are going to say QA is equals to negative 2. For nanocoulomb, we multiply by 10 power of minus 9 coulomb. We do the same with B, which is positive 3 times 10 to the power of minus 9 coulomb. Same as for C, minus 1 times 10 minus 9 coulomb. Now we have converted our charges into coulombs. Let us consider our distance as well between A and B. We must divide our distance by 100 for our distance to be in meters, not centimeters. Let us divide our 3 centimeter by 100. Then we get 0.03 meters. So simple. Do the same for B and C. Going to get 0.05 meters. Okay, at this point we have converted everything. Now we are going to use our formula, Coulomb's law formula, which states F between A and B is going to be K, QA, QB divided by R squared. Then our K is a constant value, which is 9 times 10 power 9. At this point, please don't include your negative signs, omit them. Then for A is going to be 2 times 10 to the power of minus 9. Avoid using negative signs at this point. Then our B going to be 3 times 10 minus 9. Then you divide everything by, for AB, which is 0.03 square. See? Let us use our calculators. When we use our calculators, we get 6, a negative number. 6 times 10 minus 5 Newton. Bear that a force is a vector quantity. This is our magnitude. Let me indicate the direction, which is left. Then at this point, we'll then now focus on B and C by saying F, B, and C is equals to K, QB, QC, R squared. Our K is a constant value, which is 9 times 10, 9. Our B Z is 3 times 10 minus 9. Then our C is going to be, don't forget again, omit that negative, which is 1 times 10 minus 9. You divide everything by distance of B and C is 0, 0.05. We take a square. At this point, you then use your calculator. Going to get 1,08 times 10 minus 5 Newton. Let us indicate the direction for this force. To the right. You see, to the right, between B and C. B and C to the right. Then, yeah. We haven't yet arrived at our final answer. Let us continue. Let us continue now. Now we are going to calculate our F net or FR, the resultant electrostatic force. Let me say R. Going to say F of AB plus F of BC. For AB we got 6 times 10 to the power of minus 5. At this point, we then include our negatives. At this point, when you calculate your FR, your resultant electrostatic force, or F net, we include our negative signs. Then for B and C, we got a positive 1,08 times 10 minus 5. When we use our calculator for this one, clearly we are going to get a negative number, which is 4 times 10 to the power of minus 5 Newton. Let me indicate a direction. We get a negative answer, hence I include the direction which is towards the left. You see? I hope you understood. I thank you. Have a nice one.